let's get this thing and then the thing. All right, there we are. Perfect. Okay. Alrighty. Um, let's see here. Let's move this over. Let's see here. This, maybe. Okay. All right, there we go. Hey. Okay, I think we got it. Hello, everyone. All right. How's it going, everybody? Let me go turn. Hey, how's it going, Tom? Just chilling, gonna listen in. Feel free. Hey, Sam, how are you? Hope you're doing well today. If you're gonna chill and listen in, hey, you don't have a problem with that at all. I have zero problems with that at all. Everybody is always welcome. Undo that little cord thing. All right. Hopefully, it'll be a nice, relaxing day. Once again, that's the point, to have a nice, relaxing day. That is what we're here for. I think it's been a pretty good day so far, so. Okay, we'll wait, excuse me. We'll wait we'll wait a minute or so, and then we'll go ahead and get started here with stuff for today. So shouldn't be too bad. Just really super chill, easy peasy, lemon squeezy. How's everybody doing today? You slept in on Monday. Well, you may have slept in a little bit on Monday. That's okay. There's always a replay for you to watch, so that's okay. It's all right. All right. Good. 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 Everybody, hopefully, doing great. Um, let's see here. Okay, let me ask you guys a question here for today. At the very least, I can at least start with this question, and then actually, let me do my intro, and then we'll go ahead and do this. Okay. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. All right, so today, so today, I'm doing great, Tom. I'm doing very good. I hope you're doing great, my friend. Um, uh, so today I want to ask a quick question here for everyone in the chat here in the class. And that is, let me ask if you wanted to do a shorter day today, or do you would want to do a longer day today? So a shorter day will be just the one section here today, or a longer day will be just a couple of sections here today. So I'm not sure which one you guys want to do, but why don't you guys tell me which one that you would like? So we're kind of a bit of ahead now that I've checked the schedule again. So, yeah, this is one of those days where you could just be like, if we do, today is Wednesday, Fernando. Oh, Monday. Okay, I was like, wait a second. Today's Wednesday. I'm like, whoa. Yeah, you want to do a long day Wednesday? That's Wednesday. That's fine. No, long day Monday. That's fine. That's fine. I'm more than happy to do that. That's not a. I can totally tell you are completely fried and shish kebabbed. Your brain must have been shish kebab fried yesterday for some reason. Did you stay up too long last night, Fernando? Is that what happened? Hey, Adam, how are you, my friend? Ah, you're playing Warzone last night. Okay, that kept you up most of the night there. I see, I see. I didn't get back home. I didn't actually fall asleep until pretty late. So myself, I didn't fall asleep until like 1 o'clock because I got back home at about midnight. I'm pretty good. I yesterday, Tuesday nights are my game nights. So I play D&D on Tuesday nights, and so I got back home pretty late from there, from my friend's house. But got enough rest. Feel pretty good this morning. Doing decent with doing okay with stocks today. So it's positive things. Positive things. You have 2 essays and exam due on the 18th. Oof. Oof. Well, let me go ahead and now that you've said that, Neon, let me go ahead and yeah, not make things nice for you. Unfortunately, gotta be clear here. So, I want to give a reminder here from last time. Remember that last time here, that the test here for section 1.1 and chapter 3 will be due next week. So, it'll be due next week. All right, I believe I set it for next. Let me check that one more time. But I want to say I set that for. I have so many things going on. Yeah, I set that. Okay, I did set it for the 21st. Okay, yeah. So I did set it for next Wednesday. I have like 6 classes going on. It's absolutely banana ramas. So yeah, I know. I think I set you guys a little bit later because of yeah. Okay, because I set it because of what happened last week with the computer and stuff. So yeah, you got until next Wednesday, next week, to finish up those 2 things. Last time we did the first 2 sections of Chapter 7, and today we'll just do another section of Chapter 7, just a one, since you guys want to do the short day today. And then, yeah, it'll be pretty simple and simple dimple. All right. Um, Do you guys? I know some of you may not have been here last time. Do you guys got any questions that you may have um, for me? Yeah, go ahead. If you have questions, go ahead and ask. So, do we need to know the basic graphs for the graphing? Uh, for the graphing part? Oh, well, um, I think you're confusing something there, Fernando. Are you talking about Yeah, I know x squared is like the parabola and stuff, but that's for chapter 7. Um, this is for section 1 and uh chapter 3. So this is all about the truth table stuff. Am I confused today? Uh, reasons? Oh, okay. Yeah. Okay. No, I know your brain is completely fried. Knowing the basic graphs of x squared and x to the third are very helpful. Yes. Okay, if we're talking about the beginning of chapter 7, yeah. Yeah. Note. Don't do Warzone. It's like don't do Warzone before school days. It's like my very kind of rigid rule for myself. For example, if it's like drinking or something, I don't drink before school days. So that's a very strict rule I have before myself. So only only if I'm not having school the next day, then that's okay. But never before school days. So it's like, yeah, don't play Warzone, before school days, so you don't feel so fried. I feel so bad for you, Fernando. Let's just say I learned my lesson the hard way about why I shouldn't drink before work days. Boy, that was brutal. You remember the points for the graphs? Okay, so just to give yourself a friendly reminder here, let me go ahead and bring this up here. So to give you nah, that's all good, buddy. It's all good. So if you're like having like y equals x squared, our classic example of a parabola. So again, the basic graph here. Where are you? Here you are. Okay. So our basic graph here is again a parabola that looks like this. So this is the base graph here of x squared, Fernando. All right, just like so. All right. So when we talked about, say, graphing it and stuff like that, at least you know what it will generically look like if you have, say, x squared plus 2 or something like that. Something to that effect. Okay, so like for example, points on the graph here would be like, let's say if you have 1, okay, then this point here would be, which one is 1 here? Here we go. So this would be 1 comma 1 right here. Yeah, I know it's kind of weird. So this would be 1 comma 1 right here. This would be negative 1 comma 1 right here. And then you get the general gist. So again, one of the things that I recommended from last time is for graphing, okay, make an XY chart, okay? Make an XY chart for all your points on the graph. So if you get a graph that has x squared, then get points that will reflect a parabola that looks like what you see on the screen. Or if it's x to the third, then x to the third here, x to the third here is, again, going to look something akin to this. Again, make an XY chart of that, and then you could go ahead and put it together. It'll look something like this or a reflection or whatever. Yeah, a snake. Like your math teacher, a complete snake. Yes. Who's this guy? He's a jerk. Oh my gosh. uh, all right. Good beans, everybody. Good beans. All right. Well, let's go ahead and get started here with some new material here for today. We're just going to do the one section here for today, which is going to be from section 7.3. So let's do section 7.3 here today. Okay. Alrighty. So section 7.3 may be a little bit of review material for you guys, but again, if you haven't seen it in a while, then that's okay. That's what we're here to cover. All right, so let's zoom in on this a bit more. Okay, so section 7.3. You know, I was thinking, like yesterday, I got the weirdest phone call, like something from a job placement center. I was like, you left a 3-minute message about a job placement center? Like, what are you doing, man? So, my phone's acting weird. All right. Anyway, section 7.3 is systems of linear equations in two variables. All right. So what does a system of linear equations, two variables, look like once again? Well, I think you've seen these before, maybe in the past. Again, this will serve as a friendly reminder nonetheless. So you may have seen something like, let's go ahead and put this down here. Where are you? That is not what I wanted. There you are. Okay. So you could see something like x plus 8y, all right, equals 6. Or again, you may see 2x plus 4y is equal to minus 3. So let's say we had to solve for both x and y with these two equations and two variables that were listed here. Okay, so that's effectively what we're going to be doing here in these particular problems. Now, we're going to be looking at two methods of which to find this. Okay, so let's talk about both methods about how to solve for x and y. All right. So let's talk about method number 1. Method 1 is substitution. Okay, so we're going to solve for this particular problem here. X plus 8y equals 6 and 2x plus 4y equals minus 3. So we're going to take this example we see up here on the screen, and we're going to go ahead and solve this here using the substitution method. Okay, so let's go over the steps here on how to do that, and we'll see exactly how that works out. Okay, step 1. Step 1 as part of the substitution is you're going to choose an equation and solve for one of the variables. Okay, so we have two equations here. Okay, so let's go ahead and put this in the paint tool here because there's a few things that I do want to point out here. So all right, so let me go ahead and copy this down here. Okay, so we have two equations here. So what I mean is that this is like equation 1 and this is equation 2 in our system of equations. All we need to do is choose at least one of them and solve for one of the two variables. Again, either for x or for y. Now, there is, of course, a note to go with this step here. Note, choose the equation that has a variable without a coefficient. if possible. So again, not every problem is going to have that, but what do I mean by that? Choose an equation without that has a variable without a coefficient. So for example here, you can see x, okay? X here is kind of sitting by itself. So if we see x there, we don't see really a coefficient. Technically, the coefficient is 1. So with that, I guess I should say with the coefficient of 1. Um, I guess I should say that. Um, we don't always get this in every problem because this could be 5x plus 8y equals 6, whatever the case may be. But there you go. You got it. All right. It's really not too bad. That's how we can go ahead and do that. So let's go ahead and say, all right, step 1, I'm going to choose that first equation there, equation number 1. So I'm going to have x plus 8y equals 6. All right. So all we're going to do is subtract by 8y on both sides. All right. So you get x equals 6 minus 8y. Okay? Okay, so that's step 1. Let's take a look at the next step then. And let's put that there. There we go. Okay, step 2. Step 2 is to substitute. So this is the substitution part. Substitute the equation you found in step 1, all right, for the letter you solved for in the equation you did not use. Okay, so let's go ahead and describe what step 2 means, okay? So for substitution. So the way it works is that we have x is equal to 6 minus 8y, and that's perfectly fine. Now, since we used equation 1, that means that we did not use equation number 2. So since we did not use equation number 2, we're going to take this 6 minus 8y, so this guy here, and we're going to substitute that in for x in the second equation, since we did not use that, but we did solve for x in the first equation there. So I'd like to draw a little arrow so that way I know exactly where I'm going to be plugging in that particular expression. So you can see how I did that on the screen here. That is purely by design, all right? So that way I get less confused and I can clearly see where I need to plug in that expression that I found in the first step. Okay, so that is step 2 in a nutshell. So what we have here is we have 2 times 6 minus 8y, all right, plus 4y equals minus 3. Okay, so that's what we got there. Are there any questions about that so far? No? Okay, that's perfectly fine. All right. All right, so let's move on to step number 3. All right, so step number 3 here is to go ahead and now that you see that after we substituted here, we have a remaining variable left over. That in this case is y. So solve, so using algebra, solve for the remaining variable, okay? And then step 4 here, which is the last step, which is fairly straightforward again. Step 4 here is to, again, use the result of step 3 and any one of the 2 equations to solve for the remaining variable. I'll put a note here for this and I'll point this out. you can also use the result of step 1 as well. So, okay, lots of options here. You're probably saying, whoa, 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 lots of things, lots of writing. Okay, but let's go over each of these guys carefully, and we're going to end up with an answer here for x and y appropriately. Alrighty, let's go ahead and do it. Okay, so first and foremost here, let's go on to step 3. I'll mark this in black. All right. So step 3 says, okay, use algebra to solve for the remaining variables. So we're going to start from here. All right. And now from there, we're going to go ahead and solve for y. So I'm going to distribute the 2 here. So I'm going to have 12 minus 16y plus 4y equals minus 3. Okay. Okay. Now we just go ahead and add this together here. So we got minus 16y plus 4y is minus 12y. Plus 12 equals minus 3. We'll subtract 12 on both sides. And so here we get minus 12y equals minus 15. Go ahead and divide by negative 12 on both sides. So just going the same old process here of doing our regular algebra deal. All right, and then here we have y is equal to 5 over 4. So we get 5/4 here for y. Okay, so not too bad when you're just doing the regular algebra thing like we normally do. Nothing great going on here. There it is. It is what it is, and that's pretty much it for y. Now, as for the last step here, step number 4, again, you have an option. You can use the first equation, you can use the second equation, or you can use this equation that we found here in step 1, and you can solve for the remaining variable of x. So in this case here, let's say I use this equation from where we found in step 1. So x here is equal to 6 minus 8 times 5 over 4. And so if we do that, we actually end up with negative 2. So actually we get 6 minus 10, and you get minus 2 here. So that's going to be our final answer. Now, one thing I want to stress about the final answer is uh, on the homework there for MyMathLab, they will ask you to enter stuff in as an ordered pair. So go ahead and enter in your answer as negative 2 for the x, comma 5 over 4 for y. And this is how you probably enter in your answer for MyMathLab. That's pretty much what they're looking for there. And that's it. Any questions about that? Oops. Any questions at all, guys? Let me know. No? Okay. That's fine. All right. Let's go ahead and do another example, okay, for substitution. Ah, gotcha. Well, hopefully this will shake out a little bit of the cobwebs, and hopefully I'll make it a bit easier on you, Sam. The process here is not to be, I don't want to make the process super complicated, trust me. Want to take it just one step at a time, okay? No. I can understand if it wasn't your favorite, but we'll try and make it as easy as possible for you. All right, let's try this. I'm going to step it up just a little bit, but not by much. So, okay. So we have negative x plus 3y is equal to 10, and 2x plus 8y is equal to minus 6. Okay, so let's go over the steps here on how we can solve this. We're going to do this via substitution, all right? And we're going to see exactly how we can solve for x and y here in this case. All right, so as you can see here, those are the steps that you see there over on the left. So, uh, so why don't you guys tell me here, what should I do first here based off of step 1? What should I solve for, and which equation should I choose? I should do the second equation. Okay, and which variable do you want to choose? Do you want to choose x or do you want to choose y? Okay, so you've chosen the second equation. And so let's go ahead and choose, let's go ahead and do that. All right, so we have 2x plus 8y equals minus 6. So we chose to solve for x. Oh, I meant to put that. Okay, so what should we do here first? What do you think is a good idea? Subtract 8y. Okay, let's go ahead and do that. All right, so this is what we have so far. We have 2x equals negative 6 minus 8y. So that's fine. All right, what's next? All right, divide by 2. Now remember, when you divide by 2 here, the whole equation, that's right. So everything is going to be divided by 2, just like so. Okay? So everything will be divided by 2. So don't forget that. So here we get x, negative 6 divided by 2 is negative 3. Negative 8 divided by 2 is minus 4y. All right, so far, so bueno. Okay, so this is what we have here so far. Okay, let's move on to step number 2. There we go. Okay, so where are we going to put this equation? Where are we going to put this equation in here if we're doing substitution? Where does this go? Where does minus 3 minus 4y go? Okay, very good. That's right. It will go. So let's draw our arrow here. So if you have notes, then of course it's going to be easier for you guys. But just to show you, we use the second equation here. So we're going to use the first equation to do our substitution. So we're going to plug it into that x in our first equation there. Okay. So now with that, let's go ahead and do the rest of this out here. Ah, darn. Hang on. Meh. There we go. Just need a little more space. Okay. So let's go ahead and take a look at what we got. All right. So we have negative 3 minus 4y plus 3y equals 10. So here we just go ahead and we want to solve for the next part here. So we've done our step 1, we've done our step 2, we're on step 3 now. Just doing our nice solving stuffs here. So we get, let's put this in purple. All right, so we get 3 plus 4y plus 3y equals 10. Now we just go ahead and run through the paces of regular algebra. So 3 plus 7y equals 10. Subtract 3. So we get 7y is equal to 7. So divide by 7 on both sides. So we get our answer here to be y is equal to 1. Perfect, that's correct. Okay, so that's step number 3. All right, so we solved for the one of the variables here, that in this case being y. All right, seems fair. Now we're going to go ahead and solve for x in the last step. So let's do that, and I'll put this in green. So we could take minus 3 minus 4y, and we're just going to plug that in. So we have x here. So x here is equal to minus 3 minus 4 times 1. So x here is equal to minus 3 minus 4. So that's going to equal, x will equal to minus 7. All right, and so our final answer here is going to be negative 7 comma 1. And that's it. Okay, any questions about that? So you have the option here, Fernando. You can plug it into any one of the two original equations or this equation down here. You have the option. You are thinking of one other thing, which we're going to talk about next, though, Fernando. I think I know what you're referring to. So we're going to talk about that right in just a second. So you're thinking of elimination, so in which case, yes, that's true. But we got to talk about it first, so. Hey. All right. All right, any other questions about this example before we move forward? All right, no questions about this example? Okay, well, let's move on then. Nope, okay. All right. Okay. All right, so let's, no, no, no. No, not today. Not today. Not today, everybody. Sorry for the hiccup here. Okay, that's kind of weird. Hmm. Hmm. I thought it was working just fine a second ago. All right. Well, that's okay. We'll have to run with this until it decides to settle down. Settle down for a second. So that's way too fast. No, you're fine. It's on my end that's having slight issues. Like my buffer size is really large for whatever reason. Holy smokes. That's really bad. Okay. Hopefully that works out okay. Let's try this again. Let me yeah, let me connect again and see if that's okay. I think we're okay. Okay, leave it like that. All right. Yes, no. Oh, that's super delayed. Okay. All right. Hopefully this will be a little bit better. Yeah, apologies about that. Okay, we good? Just to hit F5 to refresh. All right, good stuff. Okay. All right. There we go. Just had to fix that. Sorry about that, everybody. Okay. Let's go ahead and keep going here. Sorry, my apologies. All right. So next. So the next method we're going to do is method number 2. So method number 2 here specifically is going to refer to elimination. Okay. So let's do elimination. You guys still there? You guys good? I want to be sure you guys are okay. And again, apologies about that. So you guys still there? Yeah? Okay. All right. I just need to be sure because I wasn't sure about all the hiccups there. My bad. All right. In any case, now that that's straightened out and stuff. Okay. We're going to be talking about elimination here in this next problem. So what is elimination? Well, it's a AKA. All right, perfect. AKA, this is also called AKA the addition method. Um, so you also hear this sometimes called the addition method. So if you see that in the book, solve it via the addition method, then it's like, okay, you go ahead and get that done. All right. All right. So now that we have that, let's go ahead and talk about the steps here. Step 1, choose a variable to eliminate. So that is step 1. You're going to choose a variable to eliminate. Now the question is, how do you know which variable to eliminate? Okay, so let's talk about step 2, and that should help out with step 1 actually. So if you choose a variable to eliminate, how exactly do we choose between x and y? Well, what we're going to do here is that we're going to multiply one or both equations by numbers so that the coefficients of, the variable you chose are opposite of each other. Now, I will add a note to this here as well. Note, the numbers you multiply by can be different. Okay. All right. So now let's talk about what that means in, say, the context of this problem. So we're going to redo this problem here that we just talked about in this last example. We already know what the answer is. We know that the answer is minus 7 comma 1. But how can we replicate that answer using the elimination method over the substitution method? Because the bigger issue here is that the substitution method just takes a long time to do, and it's kind of a pain in the butt. So we want to kind of avoid pains in the butt because, well, it's exactly as it sounds. It's a pain in the butt. So let's go ahead and do this problem here once again. And we should get the same exact answer from before. So I'm going to go ahead and rewrite this out of here. All right. So we have, again, negative x plus 3y equals 10. And 2x plus 8y equals. All right. So we have the predicted result, but we want to replicate that same predicted result here. Okay. So again, we have equation 1 and equation 2, but let's go over each step here. So let's go over step 1. Step 1 is we want to choose a variable to eliminate. So why don't you guys choose? You tell me, what variable do you want to eliminate? What variable should we eliminate? You guys can choose x or y, and then we'll proceed from there. Okay, so what variable did you choose to eliminate there, Fernando? Okay, so you can make the choice here. It doesn't matter which one you choose. You could choose X, you could choose Y. Again, it just depends on what choice you decided to make at the very beginning. So we're going to choose, in this case, we're going to choose X to eliminate. So because we chose X to eliminate here, let's go to step 2. Now in step 2, let's take a look at our two numbers here. Okay, so in front of the first X, we have minus 1. And in front of the second x in front of the x in the second equation, we have 2 as our coefficient. At the end of the day, let's take a look at what step 2 means. It says multiply one or both the equations by numbers so that the coefficients of the variable you chose are opposite of each other. So as long as these are opposites of each other, like one could be -2 and one could be +2, or one could be -4 and the other one could be +4. As long as that occurs, then that's exactly what we're after here in step 2. Okay? So that's essentially our goal here in step 2. That's the big crux of the problem here in this case. So, as Fernando pointed out here, we're going to go ahead and multiply by 2 here, okay, in the first equation. So let's multiply by 2 here in the first equation. Okay, and then we're going to have, again, 2x plus 8y equals -6. So let's see what happens when we do that. So what we're going to have is we're going to have -2x plus 6y equals 20. Now, and we're going to have 2x plus 8y equals -6. Now, I do want to point out one thing here that is very important. Probably the most common mistake I see in these problems, even using elimination. Even though elimination is rather fast and easy to use, one of the notes that I'm going to point out here specifically is, this will be a second note here, note 2, is don't forget to multiply everything, okay, including the answer to the right of the equal sign, okay? This is kind of one of those things that people just say, oh, I'm just doing that left half and multiplying by 2. No, it means you multiply everything, okay? And it does mean everything, all right? So, that's the most common mistake I see on these problems quite often is people forgetting, oh yeah, I got to multiply 2 times the 10 out here in order to get the 20, okay? All right. Now, having that had the I can't say stuff right now. Having had that, step 3. Step 3 is going to be we're going to do why they call it the addition method sometimes is that we're going to add straight down. So we're going to add straight down. Okay. And then finally, this last 2 steps here is solve for the remaining variable. And then step 5, use any one of the 2 equations. And the result of step 4 to solve for the last variable. Okay. For the, I guess I'll just say other variable. All right. Okay. So let's see what we're talking about here. Again, we know what the answer is, so we should be able to confirm those results. So here we have step 3. And so we have -2 and plus 2x. That should be eliminated. That's purely by design. Now we have 14y, 6y plus 8y equals 14. 20 plus -6, or 20 minus 6. Divide by 14. And as we can see here, in this case, y is equal to 1. Okay, just exactly as we wanted from the first one when we did substitution. Then we can use any one of the 2 equations here. So you could use the first one or the second one. It doesn't matter. You'll end up with the same answer for x. So let's use the first one because that looks a bit easier to use. So we have -x plus 3 times 1 equals 10. So we have -x plus 7 equals 10. Subtract 7 on both sides. Oh, subtract, sorry. I'm thinking it's 7. What am I doing? I'm working ahead. It should be 3. My bad. Sorry, guys. I'm thinking it's 7 already, but in reality, the work should be 3 here. We get minus x here. Minus x is equal to 7. Divide by minus 1. And so here we get, once again, x is equal to negative 7, which is exactly what we wanted here. So again, our answer confirmed here using the elimination method or addition method, whatever you want to call it, is negative 7 comma 1. All right. Any questions about that? All right, any questions? No? Okay. Well, let's go ahead and try one more problem here for elimination, and then we'll talk about the next topic here. All right. Okay. All right, so let's do, which one I want to do? Yeah, okay. That's fine. All right. Oh, it should be, darn it. Should just be 11. 2x. Okay, so this is our equation here. Our two equations, two variables. All right. Let's go to step 1. We have to choose a variable to eliminate. So which variable do you want to eliminate? Again, you get your choice of the letter here. You get either x or y. You can choose to eliminate here. What variable looks good to eliminate? Again, you guys choose. And then we'll just roll with it. Y. Okay. So let's choose to eliminate y. So we choose to eliminate y. All right. Fair enough. Okay. Now that we've chosen to eliminate y, again, for step 2, we want to be able to multiply by one or two numbers here. Again, we can multiply the first equation by one number, the second equation by some other number. Okay, so that way these are opposites of each other. Now, the way you can make that determination is just take a look at, you have here, you have -4 and you have +3. Well, think of a number that's in common between -4 and 3. That's a multiple. What's a number in common between -4 and 3? That's a multiple. Yeah, that's right. So the answer here is definitely 12. That's right. So 12 is in common between 4 and 3. So if I make one of them -12 and one of them +12, I should be able to eliminate them. You could literally pick any multiple and then run with it. So 12 happens to be the smallest one, but you could have picked 24, you could have picked 36, whatever you wanted. as long as you had one of them being minus, say, 36 and the other one being plus 36y, okay, that's fine. So in this case here, that's correct. We're going to go ahead and multiply the first one by positive 3. So we get 3x minus 4y equals 11. I'm going to multiply that first one, and then the other one by positive 4. We'll have 2x plus 3y equals minus 4. Okay, so let's see what we get here once we put these things together. So what we get here is we get 3 times 3, 9x, so we get 9x minus 12y equals 33. And then here we get 8x plus 12y equals negative 16. Okay, so far so bueno. All right, so now we'll add straight down, and you notice here the y's will cancel out, so that's what we wanted. And so we're left with 17x equals 17. Do our regular old rigmarole. And then here we get our answer here for x. So our answer here for x is going to be 1. Okay, so x equals 1. Okay, no problem. So hopefully that's pretty straightforward. That's step 4 there. All right, finally in step 5, we'll go ahead and take one of the two equations, and we're going to go ahead and solve for y once we have x, which we do. So let's say I pick the, I don't know, we'll pick the first one there. So we'll take 3x minus 4y equals 11. So we'll have 3 times 1, which is what we just solved for x, minus 4 times y, which equals 11. So we have 3 minus 4y equals 11. Subtract 3. We get minus 4y equals 8. Divide by minus 4. And so here we have y is equal to minus 2. So we have our two answers here. Our final result here will be 1, comma, minus 2. And that's our final answer. All right, any questions about that? Okay. All right. Next. Let's take a look here at the next one. Not this next problem, though, but a next topic, I suppose. Before I do that, I guess, though, are there any questions anybody has? Any questions? Any questions at all? Okay, that's fine. Okay. Nope. All right. Okay, let's go ahead and move to the next part here. Wow, that's kind of unusual. Just do this here. Okay. All right. All right, the next couple of examples do highlight something very important, so we're going to go over these fairly quickly, but they do have some significance. Okay, so this one here, let's go over this example here. This is purely an example. So we'll have okay, so let's take a good look here at this problem. Gotta love that delay though. I know. I'm trying to make it as good as I can get. I'm so sorry. If you need to reduce the delay, just hit F5. I'm trying my best though, so I'm very sorry, Neon. My apologies. That's what I'm trying to do is mitigate delay. So I think my delay is like 2 seconds or so. So I'm doing my best to try and mitigate it as much as possible. So as closest to face as we're gonna get. So 2 seconds is pretty good. So all right. So let's go ahead and solve for x and y here using elimination. Okay. Now, what we're going to do here first is let's say we chose a variable to eliminate here. So I'm going to choose, in this case here, I'm going to make the choice here. I'm going to choose x to eliminate. Now, if I'm choosing x to eliminate here, I'm going to go ahead and multiply this first equation here by -4. Okay. So I'm going to choose to multiply that first equation by -4 and see what we get. So here we're going to get negative 8x minus 16y equals negative 24. And then we have the other equation here, 8x plus 16y equals 24. All right. Okay. Now our choice here was to eliminate x. All right. So that's fine. So the x's are gone. That's exactly what we set out to do. Now let's take a look at the y's. All right. Because this is where the important part's going to come in. So we add straight down like we normally do. So in this particular case, I get minus 16y plus 16y. I'm going to put in here intentionally, I'm going to put 0y. Now I know that looks very strange to put 0y, but it will highlight an important point. And this is equal to 0. Okay, so can anybody tell me what's the answer for y here in this case? What's the answer for y here in this case? We'll go. Hmm. What's the answer for y in this example that you see here? What do you guys think? Undefined is divided by 0. I can see that. Okay. Anybody else? Sam? Neon? What do you guys think? Or just 0? All right, Sam and Neon. I'm just waiting for you guys. What do you guys think? 0? Okay. How about you, Neon? What do you think? Looks like he has a long delay. Neon, there you go. Neon, you might want to refresh if you're gonna reduce your delay. I don't know if you're on. Oh yeah, that's right. You're on your phone. No wonder why it's delayed. Oh yeah, I forgot about that. Okay, sorry, my bad on that. Um, okay, okay. So the answer to this is, well, technically 0 is technically an answer. However, that is not the answer here for this particular problem. The real answer is going to be infinite solutions. Now, the reason why this is infinite solutions, let me go ahead and state this here. The reason why this is infinite solutions is because 0y, meaning to say we could plug in anything in for y. 0 times anything is always 0. That's just part of multiplication, right? If we take 0 times a billion, that's still equal to 0. So any number can go in for y, and it will still pop out 0 at the end. So you have an infinite amount of solutions just because of that case. All right, so if you run into this situation right here of like say 0y is equal to 0 or 0x is equal to 0, then you know that's going to be infinite solutions at the end of the day. Now, if you change things up just slightly, then the situation could change. So let me go ahead and do the same problem here. I'm just going to make one slight change though. So let's say I made this 23 instead of 24. I do the same thing here. I multiply by minus 4. I get minus 8x, minus 16y, okay, equals minus 24. Okay, so everything, the process here is exactly the same. There's not much going on here outside of just me changing up one number. But here's the key difference. Although we chose to eliminate x, that's gone. Okay, I still have 0y, and that's fine. But now I have negative 24 plus 23. That's going to be negative 1. And in this case here, since we've just went ahead and stated, well, 0 times anything is equal to 0, well, then can 0 times anything equal minus 1? Well, the answer is no. Nothing times 0 is ever going to equal minus 1. So if you get a case that looks like this, like 0y is equal to some number that's not 0, then this is no solution. So the key difference here between infinite solutions and no solution is basically how what you're equal to at the end. If you're equal to 0, you're fine and dandy, that's infinite solutions. If you're equal to any other number that's not 0, well, too bad, so sad, there's no solution, and then your problem's done. Okay, so that's the key difference there between both of those problems. Okay, any questions about that? No, you cannot divide by 0. Again, you're thinking about doing it algebraically, Fernando, but in reality, I want you to take a look at it what you see right in front of you. I'm not going to be dividing by 0 here. I just need to look at 0. If I'm trying to like plop in solutions, just try a solution out. 0 times what equals 0? Well, any number I multiply by 0 will be 0, right? So if I have this, any number I put in for y will work. If this was 3x is equal to 0, then I'd go ahead and divide by 3, and yeah, I agree, 3 times 0 is 0. But 0 has an unusual attribute that I can't divide by 0, okay? So I'm not allowed to do that, but if I look at it from another point of view, then it starts to make sense why we have infinite solutions for the first one and no solution for the second one. There are lots and lots of those. Lots and lots of black holes. let's rip space time together. Yeah. All right. Okay, let's focus on the next part here. Okay, next. Just have one more thing to really talk about here, and then we'll move on. Um, oh yeah, I gotta do that. All right. So the last part we're going to talk about here is a application problem here. So we're going to talk about profit, revenue, and cost. Okay. So that's the last thing that we're going to be talking about here in this instance. Okay. So let's talk about first, we're going to talk about revenue. So what exactly is revenue? Now revenue in the book here will be listed underneath R of X. So if you see R of X, that's reflective of a revenue function. But what exactly, how do we exactly determine what revenue is? Well, revenue is how much money you make by just purely selling the item. So whatever the cost of the item is, so the price of the item times the number of items sold. Okay. So typically you'll see this. You'll see P times X. And that's what you'll typically see there, where X is the number of items sold. So P is price and X is the number of items sold. Yeah. Okay. Oh, that should be equals. Okay. All right. So that's basically how it works for revenue, is you have P times X, or again, the price of the item times the number of items sold. So essentially you have R of X is equal to PX, okay? If we were to look at it as a function notation sort of deal. Now, what they'll give you sometimes in these problems, they'll give you already the revenue function, and they may end up giving you a cost function or whatever the case may be. So that might be written in. It just depends on, how it's written in essentially. All right. Now, let's go ahead and talk about a couple more things here. Next is the cost function. Okay. So let's talk about cost. So basically, the way it works is for cost functions for basic business is the cost to produce one item times, again, the number of items produced. All right. So how many of them you made and the cost it took you to make one of those. And then you have to add in one special item here. You have to add in a fixed cost. Okay. Now, what is your fixed cost here? Well, think about it this way. Realistically, if you start a business, right, of any variety, you have to take into account the equipment that you buy, okay, the employees that you pay, how much is your rent, okay, those sort of things are fixed costs, okay? So you got to put money up front before you start turning a profit, right? So that's where the fixed cost is going to come into play, all right? And so cost function here is labeled as C of X, okay? That's for the cost function here, and that could literally be a lot of different things. So, all right, now we're going to, where is it here? Okay, all right, cool. All right, and then finally we have a profit function. So profit, how do we determine profit here? So profit here excuse me, is determined by the function here of revenue minus cost. So revenue minus cost here. So profit is labeled as P of X, which equals R of X minus C of X. Okay? So we're going to see about there. That's so if we want to determine how much profit we make, we take the revenue minus the cost, and then we're going to, again, have profits on the table if the revenue outstrips the cost to make those products. Finally, there's one more thing I'd like to acknowledge here, and that is the break-even point. So basically, the break-even point is the number of items you have to sell before you start turning a profit. So because it costs money to, of course, make stuff, well, then you're going to put a big money sink into like the very beginning of the business. So until the time you start actually making money and start making profit is when you go ahead and sell enough items to go ahead and start turning in the green instead of being in the red. So, or in the black, I should say, if you want to say that too. In the black means in the green. All right, so meaning to say here, what is the break-even point? There is a formula that goes with this. This basically means that where the revenue here is equal to the cost. So where revenue is equal to cost is where we can find the break-even point for a particular item. Okay, so it could cost some money to get to that point, but you know, it is what it is. So, all right. Now we're going to go ahead and do a specific problem here. All right, and we're going to find each one of these three guys, and it's not too hard. It does take a little time, but it's not like it's super difficult. It's just have to read the problem carefully. So let's do our example here. So a company that makes small canoes has a fixed cost of $18,000. I got the dollar symbol there. So has a fixed cost of $18,000. All right, so period. It costs 20 bucks to produce each canoe. The selling price is $80 per canoe. Okay, so what we're going to do is we're going to do three things. We're going to be this last thing, yes. So the first one here, A, is we're going to go ahead and find find the cost function. All right, C of X. All right, find the revenue function, R of X. All right, state the profit function, P of X. Gosh darn it. And then find the break-even point. Okay, so we're just going to do these four things. It seems like a lot to do, but in reality, it's really not. So let's take a look at the cost function here. Okay, so the cost function here, it takes, again, it's the cost to produce one item times the number of items produced. Okay, so can anybody tell me what would be the cost function here in this example? What would be the cost function here in this example? We're also going to make one assumption here, by the way, just so it makes it easier for you guys. X is going to be the, where are you? the number of canoes sold or made. Okay, so number of canoes sold or produced. I guess I'll say produced to make it easier. So it's $20 to make every canoe, right? That takes $20. So it'll be 20. So the cost to produce one canoe was $20 times the number of items produced, which will be X, plus our fixed cost to manufacture, of course, the equipment and all that jazz, okay, is going to be plus 18,000. So this is going to be our cost function. Does everybody see how I came up with that? Again, $20 times X, so again, $20 per canoe to make, plus $18,000, which is our fixed cost before we even produced one canoe. All right, any questions about that before we move on? Okay. If there are no questions, we'll go ahead and move on then. All right. Now let's state the revenue function. So the revenue function is, what's going to be the revenue function? So what's the revenue function? What do we have here for our revenue function? How much it costs to make to sell every canoe in this problem? All right, 80x is correct. Very good. That's right. All right, so 80x costs 80 bucks to sell the canoe, and by how many we sold, we don't know, but 80 times x is going to be our guy here. Next, we're going to state the profit function. Now, here's what's very important about this. This one I'm going to do out here because of one very important thing. Okay, so the profit function here basically says this is going to be the revenue function minus the cost function. Now, the subtraction here is actually fairly important. So we're going to have the revenue function, which is clearly 80x, but we're going to subtract by the quantity of 20x plus 18,000. What this means is that, an important note, you'll distribute the negative sign. Okay, so this is one of those things that is pretty important to know, is that we need to distribute that negative sign here in that second half. So what we're going to get here is specifically is that the profit function here is going to equal 80x minus 20x minus 18,000. And so that's going to be 80 minus 20x, so that's going to be 60x minus 18,000. So that'll be our profit function right there. Okay, so don't forget to distribute that negative sign. That'll be very, very important. All right, so I wanted to show that one out because that usually gets people about, kind of confuses people sometimes. All right, finally, let's do D, the break-even point. Now remember, the break-even point is where the revenue is equal to the cost. So what we have is we have the revenue, R of x, is equal to C of x. So what that means is that we're going to get here, yes, that's nice. Thanks for doing that. Okay. Okay. All right. In any case, Oh, come on now. Stop, stop, stop. All right. So this last part here, we're going to have 80x equals 20x plus 18,000. All right. Can you guys hear me? Sorry, it kind of stuttered again. I don't know if you guys. So no. Okay. Frozen. Okay. Dang it. Okay. I think that did it. Yeah. Sorry about that. I can't help that. I don't know how to really deal with that. Um. I'm trying not to get it frozen. Trust me. Yeah, I know it's delayed. So. All right. All right. In any case, let's go ahead and finish this stuff up here. So here I have 80x is equal to 20x plus 18,000. That's the revenue is equal to the cost. Okay, if we're going to find the break-even point. So we'll subtract 20x on both sides. Okay. And so here we're going to get 60x is equal to 18,000. We'll divide by 60 on both sides. And then we'll have x is equal to 300, yes, 300. So 300 canoes before we actually start breaking even. So there we go. If we sell 300 canoes, we'll start turning a profit. Okay. Any questions about section 7.3? Okay, which part? Okay, so this way I got the solution here is I have the revenue is equal to the cost function. So I took the revenue function, which was 80x, and then I had that equal to 20x plus 18,000, which I got from the first part. So then I just set them both equal to each other. So I actually have, again, 80x equals 20x plus 18,000. And then I just solve for x after that, just doing some algebra, as you can see on the screen here. I just subtracted by 20x on both sides, and then divided by 60, and then I was able to get 300 canoes until we broke even. So again, this is the break-even point where revenue and cost are the same exact value. And that's why I set it up that way. All right, cool. All right. Hopefully everybody's all good. All righty. Very good. Okay, any more questions? Any more questions at all? Hopefully that should be okay. Yeah, you must have a long delay. It's okay. I understand though. Oop. Better spell your name right. Okay. If there are no questions, all right, so if there are no questions, we are going to end off here for today. All right, so if there are no questions, we're going to end off here for today. So next time on Monday, we are going to go ahead and do sections 7.4 and 7.5. So we said that'll be a long day on that day, so that should be all right. Okay, so again, that should be okay for a long day on Monday. So 7.4, 7.5 for next time, or 7.5. Maybe I'll skip 7.5. I don't know. I'll figure it out. In any case, all right, that'll take care of it today. All right, everybody, I want to thank you all very much for coming out to the stream. Sorry it's kind of hiccuping in and out, but yeah, I think we did really good today. So great job, everybody here today. And everyone have a very wonderful weekend, okay? Have a great and wonderful weekend. All right, everybody, please take care of yourself. All right, have a great one, and we will see you all later. All right, take care, everybody. All right, all right.